Hello. In this example, we are taking a look at another integral where we see a quadratic under a square root. Now, in the last video, I mentioned checking to see if it nicely factors into something that will help us. But the factorization of 7 minus x squared minus 6x is 1 minus x times 7 plus x. And if I put that under a square root, there isn't any simplification that can end up happening as a result of that. The square root won't cancel away because it's not a perfect square trinomial. And so since factoring doesn't help this integral, we're going to switch to trig sub and see about completing the square like we did in the last problem. So we want to complete the square on our denominator of 7 minus x squared minus 6x. We want to separate off the x terms. So I'm going to keep this negative out front and factor out the negative from both the x squared and the 6x to have x squared plus 6x in parentheses. And now complete the square on x squared plus 6x. We take the 6, divide it by 2, and square it. So 6 over 2 squared is 9. So we add 9. We have now completed the square on the trinomial, but we've unbalanced our equation. These two lines are no longer equal to each other, but we want them to be equal. Meaning this 9 I just added, I need to get rid of it. However, I did not actually add 9. I actually subtracted 9. So because I subtracted 9, I want to add 9 to keep it balanced. And adding that 9, 7 plus 9 is 16. And the x squared plus 6x plus 9 factored in or turned into a perfect square trinomial that factors into x plus 3 squared. So this square root is going to turn into the square root of 16 minus x plus 3 squared. We now have in the denominator a form of a squared minus x squared. And when we have the form a squared minus x squared, we want to use the substitution x equals a sine theta. A in this case is 4, and x is going to be the x plus 3. So the substitution we're actually making is x plus 3 equals 4 sine theta. A few more things this means. Taking the 3 to the other side, this means x equals 4 sine theta minus 3, which we will use to replace the numerator x. And it also means dx equals 4 cosine theta d theta. So we can replace everything in this integral with thetas. But since we're changing variables, because we have bounds, we need to change the bounds as well. So I'm going to take these bounds and plug them in to my original substitution equation. They are bounds in terms of x, so they're getting plugged into x. So if x equals -3, we get -3 plus 3 equals 4 sine theta, or 0 equals 4 sine theta, 0 equals sine theta. The first place that 0 equals, or theta, will give sine being 0. First place that happens that we care about is theta being 0. So our new bound for when x is -3 is going to be 0. And if x equals -1, we have -1 plus 3 equals 4 sine theta, or 1/2 equals sine theta. And when sine theta equals 1/2, theta is pi over 6. So the upper bound is going to become pi over 6. The lower bound will be 0. Giving us the integral from 0 to pi over 6. X is 4 sine theta minus 3. The square root is 16 minus x plus 3 squared, or 4 sine theta squared. And d theta, or dx, is 4 cosine d theta d theta. Some simplifications. 4 squared is 16. So the square root in the denominator is 16 times 1 minus sine squared theta. Numerator is still 4 sine theta minus 3, and we still have the 4 cosine theta d theta. The whole point of doing the trig sub is that 1 minus sine squared theta is cosine squared theta. And the square root of 16 cosine squared is 4 cosine squared. The 4 cosine thetas, one is in a numerator, one's in a denominator, they cancel, giving us the very nice integral of 0 to pi over 6. Of 4 sine theta minus 3. Can take this antiderivative and evaluate at the bounds. And the antiderivative of 4 sine theta is -4 cosine theta. And the antiderivative of 3 is 3 theta, which we are evaluating from 0 to pi over 6. Plugging in our upper bound, we get -4 cosine of pi over 6 minus 3 cosine, minus 3 of pi over 6. Minus, now we plug in the lower bound, -4 cosine of 0 minus 3 times 0. Cosine pi over 6 is √3 over 2. 3 divided by 6 is 1/2. So that turns into pi over 2. minus cosine of 0 is 1. And 3 times 0 is 0. One last simplification, -4 divided by 2 is -2, leaving us overall with -2 square root 3 minus pi over 2 plus 4. And with that being the whole page, zooming out, we can see we have found the integral from -3 to -1 of x over the square root of 7 minus x squared minus 6x.